Morning, welcome to today's talk about Miller indices. Miller indices concept was introduced by Miller scientist. The name of the scientist is Miller. According to Miller, what is meant by Miller indices? Let's see. A group of three numbers that indicates the orientation of a plane or set of parallel planes of atoms in a crystal. In a crystal, the atom's orientation is indicated by set of three numbers. So we know that crystal is a three-dimensional object where the atoms are a repeating pattern. So here the atom's orientation is expressed by group of three numbers. That means the orientation of a plane of a atom in a crystal. The orientation of a plane of a atom in a crystal. In a crystal, whatever atom is there, its plane orientation is explained by three numbers. So that three numbers are Miller indices. We also have another definition. What is that? Miller indices are the reciprocals of the parameters of each crystal phase. So each crystal phase parameters reciprocal is considered as Miller indices. Miller indices are the reciprocals of the parameters of each crystal phase. For example, we are going to consider a crystal structure. In the crystal structure, we have X, Y, Z directions. So similarly, we have three phases. What is pink, green, yellow phase? In a pink phase, the parameters are 1, infinity, infinite, and infinite. In green phase, the parameters are infinite, infinite, and 1. In yellow phase, the parameters are infinite, 1, infinite. So these parameters, when they are changed into a reciprocal form or inverted form, then these parameter reciprocals are considered as Miller indices. Then, what are the characteristics of Miller indices? If a Miller index is 0, then the plane is parallel to that axis. The plane is parallel to that axis. Second point, if the Miller index is small, then it is more nearly parallel to the plane. It is more nearly parallel to the plane. If the Miller index is larger, more nearly perpendicular to the axis. This is perpendicular, smaller one is parallel, larger one is perpendicular. Next characteristic. When Miller index is multiplying or dividing by a constant, there is no effect on the orientation of the plane, no change in the plane when it is multiplied or divided by a constant. And finally, Miller indices are very small. That's it. Your question is that how to determine, how to evaluate Miller indices on a crystal structure. For that, we have certain rules. See the rule? Determine the intercepts of the phase along the crystallographic axis. What are the crystallographic axis? X, Y, Z are the crystallographic axis. On the crystallographic axis, we need to determine intercepts. Then the intercept should be converted into reciprocal forms. Reciprocal form. In the third step, they need to change into all fractions. So in the fraction form. So finally, if it is possible, we need to reduce it into lowest form. For example, let us consider x, y, z intercepts are 2, 1, 3. X, Y, Z axis, crystallographic axis. Upon the crystallographic axis intercepts are 213. So your question is that we need to find out Miller indices. So what is the first step? The first step is we need to consider intercepts. So what are the intercepts? 213. What is the next step? They need to consider into reciprocal. So that is 1 by 2, 1 by 1, 1 by 3. Then after we need to change into all fractions. So what is the LCM? 2, 1, 3, 6 by 2, 6 by 1, 6 by 3. That is 362. Then if it is possible, change into lowest form. Otherwise, keep like that only. That is 362 is the answer. Like that, we are going to find out Miller indices. We have some task. So let us consider a particular crystallographic structure. It is x, y, z are the crystallographic axis. Upon the x, y, z, some of the parameters are there. So what are the parameters? The parameters we need to consider as intercepts. So on x-axis, the intercept is what? 2, where a is the unit. Where a is the unit. On y-axis, the intercept is 1. On z-axis, the intercept is 2. Then find Miller indices. So here on xyz axis the intercepts are 2, 1, 2. Now what is first step? We need to change into reciprocal form. Then after we need to change into all fractions. So then 1 by 2, 1, 1 by 2. So the answer is 1 to 1 is nothing but Miller indices. We have another task. See here. On x-axis, the intercept is 1 by 2. On y-axis, it is 3. On z-axis, it is 2. So 1 by 2, 3, 2 are the intercepts on x, y, z. See, 1 by 2, 3, 2 are the intercepts of x, y, z. What is the first condition? Then we need to change into reciprocal form. Then we need to change into whole fractions. So that is 1 by 2. 1 by 1 by 2, that is 2. 1 by 3, 1 by 2. Then the same is how much? That is on 6. So 6 into 12, 6 by 3, 6 by 2. That is 12 to 3 are the Miller indices. And finally, task 3. In the task 3, x, y, z. So we are not finding anything on x. That's why it is called infinite element. And y-axis, it is 1. On z-axis, it is 1. Then what is Miller indices? So here, as usual, on x-axis infinite, y-axis 1, z-axis 1. There infinite 1, 1 are the intercepts of x, y, z-axis. Then reciprocal form 1 by 0, 1 by 1, 1 by 1, then 0, 1, 1. And finally, the intercepts are 0, 1, 1. So that's it. Thank you.